All right, and welcome back. So in this video, we are going to be going through a bunch of different review problems and examples of our transformations within the coordinate plane. We're going to be going through translations, reflections, rotations, and dilations. So without further ado, let's begin. I want to start out with the general transformations review list and just generally speaking, what we do when we're performing each individual transformation. For translations, again, our quote-unquote word is slide, so the shape is sliding within the coordinate plane. We're going to add or subtract each x and y value per the rule that is given to us. So if it says we're shifting the quadrilateral 4 units right and 2 units down, well, if we're going right, we'll be adding 4 to our x. 2 units down would be subtracting 2 in our y. For reflections, our easier word for it is a flip. So we're going to be flipping the shape within the coordinate plane over the line of symmetry. And typically, we are going to be seeing that within the x-axis and over the y-axis. When we reflect over the x-axis, the y value becomes the opposite. And when we reflect over the y-axis, the x value becomes its opposite. Within rotations, we can think about them as turning the object on the coordinate plane. We have 3 different rotations we have discussed. We talked about 90 degrees clockwise. When that happens, we flip the order of the x and y and take the opposite x value, and that's the original x value. Within 90 degrees counterclockwise, we again flip the order of the x and y and take the opposite original y value. And lastly, we have 180 degrees. We leave in the same order. So it's still going to be the x comma y, except we're taking the opposite x and y values. And lastly, we talk about dilations. Within a dilation, we're going to be multiplying each x and y by the given scale factor. Now, there's 2 possibilities here. Either the scale factor is less than 1, we call it a reduction, or it's reducing its size. We can think of the word shrink. Or the scale factor is greater than 1 and is going to be what we call an enlargement, or the shape is getting bigger. So without further ado, let's go and take these rules and apply them to some examples. So let's talk about a translation. They're giving us the rule here. It says we're starting out with x comma y, and then we're going to be taking that x and subtracting 1, taking the y and subtracting 5. And we're given these 4 coordinate points. So what I'm going to do first is I'm going to graph what we call the pre-image. This is the shape before the transformation is occurring. So I'm going to graph all these 4 right here. Going to be graphing our 4 original coordinate points. So C is 2 comma 1. D is 1 comma 4. E is 4 comma 5. And F is 5 comma 1. So this is our pre-image. And what I'm going to be doing is I am going to be shifting it 1 unit left and 5 units down per this rule. Okay, that's just the visual for what I'm going to be eventually doing. But in order for us to do that, let's apply the rule first to make it easier on us. So C prime is going to be 2 minus 1, which is 1, comma 1 minus 5, which is negative 4. So I'm going to graph 1 comma negative 4. 1, 2, 3, and 4. Now let's just double check and make sure that this occurred properly. Well, I went 1 unit left, and I went 5 down. 1, 2, 3, 4, and 5. So far, it's looking pretty good. All right. What about D prime? Well, starting out with 1, 1 minus 1 is 0. Starting out with 4, 4 minus 5 is negative 1. So going to be 0 comma negative 1. Then we have e prime. E prime is 4 minus 1, which is 3. 5 minus 5, which is 0. That's e prime. Here we go. And then we have f prime. Starting with 5 minus 1 is 4. 1 minus 5 is negative 4. So we graph 4, comma, negative 4. And this is our image. Awesome. Nice job, folks. Let's keep it rolling. In this example, we're reflecting across the x-axis. So I'm just going to highlight for us the x-axis. So we're going to be reflecting across there. So what I'm going to do, nope, I don't want that. What I'm going to do is I'm going to graph the quadrilateral first, and then we're going to reflect it. So G is negative 3, 1, 2, 3, negative 4, 1, 2, 3, 4. Okay, F is negative 4, negative 2. E is negative 1, 1. And D is negative 2, negative 4. So this is our pre-image, and now what we're going to be doing is we're going to be reflecting over that x-axis. So the rule is when we reflect over the x-axis, the y value changes. So if we're going to be applying that for G prime, the x stays the same and my y becomes positive. For F prime, my x stays the same, my y becomes negative, or positive, I should say, sorry. For E prime, my x stays the same, my y becomes its opposite, so now it's negative. And for D prime, my x stays the same, my y becomes its opposite, so now it's positive. So now we're just going to graph this. T is negative 3, 4. F prime is negative 4, 2. E prime is negative 1, negative 1. Notice how this is now on the underside of the x-axis. And D prime is negative 2, comma 4. So while this may not be the perfect shape of it, you can notice that it's all equidistant from that x-axis. So if I were to count the distance here, we have 2 units from F and 2 units from F prime. And that's a good way for you to visually determine whether or not you performed the transformation of reflection correctly. Nice job. Here we go. Let's keep it going. Rotation 90 degrees counterclockwise about the origin. Well, counterclockwise, let me think back to my rule. If it's x, y, that changes into, I know it goes y, comma, x, but I need to think a second. Does it become negative y, positive x, or does it become y, comma, negative x? Counterclockwise. Let's think back to our rule. Well, if we think back to our rule, we know that it becomes the opposite y value. So what I'm going to do first is I'm going to graph the pre-image, and then we're going to apply the rule. So t is 1, comma, negative 3. U is 2, comma, 0. U, V is 5, comma, 0. And W is 3, comma, negative 1. It's an odd shape, but that's okay. So now we're going to be rotating 90 degrees counterclockwise. Counterclockwise means we're going that way. So this entire shape should now be within this quadrant. Let me erase all that. That way it's a little bit easier for us to see. So let's see what happens. So T prime is we switch our x and y, but we take the opposite y. So the y is currently negative 3, so now it's going to be positive 3, comma 1. U prime is going to be the opposite of 0, which is still 0, comma 2. V prime is going to be the opposite of 0, which is still 0, and my x stays the same. And W prime is going to be the opposite of negative 1, which is positive 1, and my x of 3 stays the same. So now, let's graph them. So we have 3, comma 1. We have 0, comma 2. We have 0, comma 5. And then we have 1, comma 3. Notice how we include the apostrophes because that tells us, hey, a transformation occurred. If you had 3 different transformations, it would be the label and then 1, 2, 3 apostrophes. But since we only had 1, we're only going to have 1 apostrophe. And that's how we do 90 degrees counterclockwise within the coordinate plane. Nice job. Here we go. Last one. So performing a dilation of 1.5 about the origin. Now, since we have 1.5, this is our scale factor. And since it's bigger than 1, it's going to be an enlargement. All right, so I'm going to graph the pre-image and then I'm going to apply the dilation to our image. So we have -2, 0. We have 2, 2. And we have 3, -1. Okay. So this is our pre-image. Now let's apply our enlargement or our scale factor. So we're going to multiply -2 by 1.5 and we get -3. 0 times 1.5 is still 0. We're going to take r was 2, 2. We're going to do 2 times 1.5, which is 3, and 2 times 1.5, which again is 3. And now we're going to take q. It was 3 times 1.5 is going to give us 4.5 or 4.5. Then we're going to do -1 times 1.5, which is -1.5. And now we're going to graph it. Let's see what happens. So we get S prime, R prime, and now Q prime. Now, since it's 4.5 and -1.5, it's going to be a little bit tough for us to be precise with this, but that's okay. We're just going to do our best. It's going to look somewhere around there. So as you can tell, our image, the blue figure, is bigger than our pre-image, which was the black figure. Okay, so long as your picture matches the rule of it being an enlargement or a shrink or a reduction, we say formally, then you are good. It's always good to have this visual example with us. That way we can match and make sure when we're confident with our transformations. Everyone, great job. If you have any questions, please feel free to reach out, but we're so proud of you. Have a good one.